Bismillahirrahmanirrahim. So today we're continuing, that's about calculating the lambda max of organic compounds का absorption maximum calculate करने के लिए. तो हमारा थर्ड टॉपिक है, पहले दो में हमने कवर किया जब हमारा बेस था the butadiene type, whether it is cyclic or acyclic. अब हमारा दूसरा पार्ट जो है, that's the third part, calculating the lambda max of compounds जिनमें alpha beta unsaturated carbonyl function present. So इस पार्ट में we'll discuss calculation of lambda max इन compounds में जिनमें alpha beta unsaturated function मौजूद हो, इस तरह का function मौजूद, इस तरह का function मौजूद alpha beta. अब ये function group मान के चले, this is alpha position, this is beta. तो अल्फा बीटा के दरमियान डबल बॉन्ड एंड देन वी हैव कार्बोनाइल. सो अल्फा बीटा अनसैचुरेटेड कंपाउंड्स को हम कैलकुलेट करेंगे टुडे. So we'll talk about in this lecture calculation of lambda max when we have alpha beta unsaturated carbonyl fragment present, carbonyl compounds. So in today's lecture we'll deal with calculation of lambda max when we have alpha beta unsaturated carbonyl present. Fine. So when we have alpha beta type of unsaturation present here, so we'll take the base value as 215. So we'll take the base value as 215 millimicrons. Fine. अब इसको understand करने के लिए let's take the example straightforward. Let's have a compound like this. This is our compound. Here we have two methyl groups. This is methyl group 1, or I mean to say the alkyl group. So two alkyl groups is another alkyl group. So we have alpha beta unsaturated fragment here. So the first step is that we have to locate this alpha beta fragment, right? So that will get the base value. The base value. So that will take as 215. Now यहाँ पे ये important है कि sometimes ये जो अल्का ग्रुप अगर यहाँ पे आपका कोई हैलाइड है present या H है, then this alpha beta base value will also vary. So for the moment, if you have this type of functionality present and we have alkyl group here, so you have the base value 215. अब देखिए इसमें अब हमारे पास सबस्टिट्यूएंट्स है, एक दो, यहाँ एक और दो. For each alkyl, अब यहाँ सबस्टिट्यूएंट्स अल्फा पोजीशन पे हो सकते हैं बीटा पे, अब यहाँ भी सबस्टिट्यूएंट्स है बीटा में. Now for each alkyl group present at the beta position, the contribution is 12. So contribution of alkyl group is present at the beta position, so that is 12. अब 12 में हमारे पास है 2, so 12 into 2, that is your 24. Fine. So this is your 24 value. So the total will become 215 plus 24, that is 459, that's 239. So the calculated absorption maximum for this type of compound, the alpha beta type of ketonic compound, okay, so that is 239. अब यहाँ थोड़ा सा याद रखना, if this at this carbonyl, if this we have a different group here other than alkyl. Now let us say we have H here, ये बहुत ही important है. So just rub it here. If we have alkyl group here, ये बहुत important है, तो उसमें base value change हो जाता है. For example, if we have alkyl like this, our base value is, so if you have alkyl group here attached to this carbonyl, the base value will be 215, जैसे हमने इस example में भी लिया. Now instead of this, if you have H as a base value, so then the base value will become, that is around, if you have H here, so the basic value will turn out to be around 27. So कम हो जाता है, ठीक. Likely, so sometimes we can have the here hydroxyl group, जैसे carboxylic acid इसमें. So if you have H, that means we have basically here aldehyde function. If you have alkyl or methyl, so that means we have this alpha beta ketone, unsaturated ketone. Now if it is OH, third possibility, if it is OH at this position, so it's like acid functionality, alpha beta unsaturated acid. So the base value is, so that will be around, if you have acid here function, the base value will be around 193 millimicrons. Fine. Same is the case अगर यहाँ पे हमारे पास OR which is ester group, then this become ester function here, alpha beta unsaturated ester. So the base value will become same as acid, that's 193. तो ये थोड़ी सी इंपॉर्टेंट चीज है, यहाँ पे याद रखनी है कि बेस वैल्यू अल्फा बीटा अनसैचुरेटेड में चेंज हो जाएगा, इट डिपेंड्स ऑन दिस ग्रुप. बाकी यहाँ कौन से ग्रुप्स होंगे अल्फा और बीटा पे, दैट वी हैव टू ऐड टू द बेस वैल्यू, हम जानते हैं. फॉर एग्जांपल इफ यू हैव दिस टाइप ऑफ फंक्शनैलिटी प्रेजेंट where we have a methyl group here, the base value is 215. If now we have instead of this H, so the base value is 207. If you have OH here or OR ester, so the base value is 193. So in the example number 1, जैसे हमने ये लिया, since we have CH3, so base value is 215. Then we have two substituents at beta position. So the contribution of alkyl substituents at beta position is 12. We have two groups, 12 and 2, that's 24. So the calculated absorption maximum is 239. Fine. I will take example. Next example. First we take the example of a compound here. Let's take the example of a compound. Let's have a compound like six-member ring. That's carbonyl here. अब देखिए यहाँ पे carbonyl, this is alpha position, this is beta position. Let us say we have this type of compound. Fine. So अगर इस type of compound में calculate करना हो the lambda max, so now look at this alpha beta unsaturated, so the base value, we'll write the base value for calculating the lambda max 215. अब देखिए इस position पे we have this is considered to be alkyl substituent here, so it is 215 millimicrons. Fine. Now what are the additions here? अब देखो अल्फा पोजीशन पे कोई एडिशन, बीटा पोजीशन पे this is one addition here, second alkyl, so they are considered to be two alkyl substituents. So the contribution of alkyl substituents at the beta position, 2 into 12, so that's 24. अब देखिए अगर आप इस रिंग को देखेंगे, that this double bond is an exocyclic double bond. ये exo है इस रिंग में, this bond is exo to this ring. So हमने पिछले examples में भी देखा था exocyclic double bond has a contribution, and this exocyclic double bond is here in conjugation with this, so it has a contribution of around the 5 millimicrons. So exocyclic double bond, so contribution of exocyclic double bond is 5, so that becomes 215, 24 and 5, it's around that is 244 millimicrons. So this way you can calculate the example number 1, alpha beta carbonyl compound. We'll take one more example here. Let's have another example. So it was, remember, it was alpha beta unsaturated ring present in the form of cycle, right? Now we'll take one more example. Let's have a compound like this. Another 6-membered ring. Please forget me here, so I'm drawing a little bit rough type of diagram. 6-membered ring, then we have a carbonyl group here. Fine. Then we have a methyl group here, alkyl group. And then at this position we have OH group present. Then we have an unsaturation, there's another CH3 alkyl group. So this is the compound. We have to calculate out of X. So first of all, this is this function alpha beta unsaturation present. So the base becomes, and then we have alkyl substitutes here. So the base becomes 215 millimicrons. Now, are there substituents on this? This is your alpha position. This is beta. So we have alkyl group at the beta position. So alkyl group at the beta position, हमने बोलता that's equal to 12. Fine. So the alkyl group at the beta position is 12. So beta position where we have, this is one alkyl group, another alkyl group. So contribution of alkyl groups which are the beta position, that's 12 into 2, that's 24 millimicrons. Now, is there anything else here? Alpha position पे we have a hydroxyl group. The alpha position पे we have a hydroxyl group here. Look at this. So the contribution of hydroxyl groups को याद रखना है. In case of alpha beta unsaturated compounds, the contribution of hydroxyl group at the alpha position. अगर alpha the hydroxyl group is present at alpha position. दिखाएंगे. So on this carbonyl type of compounds, alpha beta unsaturated, if at alpha position we have the hydroxyl group, then the contribution is equivalent to 35. So if you have the hydroxyl group alpha position, then you have to add 35. And if it is at beta position, you have to add 30. So the contribution decreases at beta position. Now since this is at alpha position, alpha, so the contribution of hydroxyl group is present at the alpha position. So that is 35. So I think this is what we have in this compound. So do we have any ring residue? No. So do we have any type of yeah, now this is important to say, this double bond, it is ring residue present here. Oh no, this is not double bond, that's carbonyl. So ring residue means we have here, so we have a ring residue here, so that is already done. That is 2 alkyl substitute as a ring, that's 24 done. So we have alpha position hydroxyl, that's also done. So yeah, that's all about. So this is equivalent to 24 to 15 4. So this is around 274 millimicrons. So this is the lambda max of this compound calculated, and it's very closer to the theoretical. In case of the experimental value, it's around 275. Fine. So this is one more example. Now let's try to get one more example before I finish this. Let's try to get one more example before we finish this अल्फा बीटा. अब यहाँ पे मैं ये कहना चाहता हूँ कि इसमें एग्जाम्पल्स तो बहुत सारे आएंगे, लेकिन so we are basically dealing this UGPG level. तो इसके लिए so we take a compound like this type of compound. So a 7-membered ring, this is your 5-membered ring. Now अभी तक हमने पढ़ा था when you alpha beta in the chain form or it is in the form of the cyclohexene type ring. Now it becomes, example is cyclopentene type. Now ये important है. Then we have a substituent here. Alkyl substituent is considered to be the alkyl point. So whenever you have a bond like this, means CH3, an alkyl. And then we have in this example something here also. So a lot of concepts here. So for this type of example, we have to search first alpha beta. So this is alpha beta here. And then we have, now it's a ring now, cyclopentene ring. Now in the cyclopentene ring, the basic value is 202. It's very important. So you can write down if we have alpha beta unsaturated function in this type. So 6 members, so the base value is 250 millimicrons. But if you have this cyclopentene type ring, so the base value is less, it's 202 millimicrons. So the base value is in the case of cyclopentene type ring is different, right? This is cyclopentene ring यहाँ पे alpha beta. So the base value is, for calculating the lambda x, is 202 millimicrons. Fine. अब substituents की बात आती है यहाँ पे. So this is your alpha, this is your beta. So there's a substituent at the beta position. Now substituent at the beta position contributes 12, हमें पता है. So we have alkyl substituent at beta position. तो उसकी वजह से contribution is 12. उसके बाद if there's anything more, now if we look at this is a ring here. Now ये यहाँ पे exocyclic double bond. इस ring को मान ली तो ये bond देखो it's exocyclic to this ring. So we have one exocyclic double bond. So the contribution of exocyclic double bond, that is bond, means exocyclic double bond के लिए हमने previous में देखा, that's 5 hours. So that's 5 contribution. Now if there's anything more, there's anything more here. और दूसरी चीज ये डबल बॉन्ड इज कॉन्जुगेशन विद दिस. हमने पहले लेक्चर में पढ़ा व्हेन वी हैव डबल बॉन्ड इन कॉन्जुगेशन विद दिस टाइप ऑफ द, वहां पे ब्यूटाडाइन था, यहाँ पे अल्फा बीटा है, बट दिस इज इन conjugation with this system. देखिए, say alternate single double. So that means now we have a double bond in conjugation. So we have a double bond in conjugation. Contribution of double bond in conjugation में कहा था वहां पे 30 millimicrons. Fine. And then if you have anything more, so this is alpha beta. ये थोड़ा सा strong compound है. यहाँ पे फिर ये गामा बन जाता है पोजीशन, क्योंकि यहाँ पे contribution double bond in conjugation से alpha beta and gamma. Now gamma पे अगर आप थोड़ा सा देख ले, we have gamma पे this is considered to be a ring residue. It is substitute here, the gamma. So if we have a residue, alkyl residue at the gamma position, so the contribution becomes, in the gamma position it's 18 millimicrons. इतना ही नहीं है, थोड़ा सा कॉम्प्लेक्स बन रहा है ना. यहाँ पे डेल्टा पोजीशन भी आ रहा है. अब डेल्टा पोजीशन डबल बॉन्ड है ना, तो यहाँ पे भी एक सब्स्टिट्यूट. So when we have ring residue, when we have alkyl residue at the delta position, so the contribution becomes another 18. तो बहुत ही कॉम्प्लेक्स, प्लस all the concepts जो इस मॉलिक्यूल में मौजूद है. So इस तरह का कंपाउंड अल्फा बीटा and such base value 22, alkyl at beta position, that contribution is 12, exocyclic double bond, the contribution is 5, double bond in conjugation, the contribution is 30. Now on the double bond we have gamma and delta position, so I have a substituent here at the double bond, the ring residue, that contributes 18, and at the delta position the contribution is 18. So if we sum these, it will become equivalent to around, so it's around 285. So 285 millimicrons. So this is the calculated value. A very complex example थी, then we can do it many times. So I believe this is enough for the day. If it's possible, I will search some more example tomorrow, and that's enough for the day. Otherwise, this is all about the Woodward Fieser rules. So if any question, please attack here again. This is makandchem@gmail.com. All for the day.